Pratap, if you are hearing me. Okay. So, yeah. So, after learning about apparent and real depth, one question more I want to give you basically. I think the bird and the fish question we did in the yesterday's class, and that makes the concept very clear that, give me a second, you are going for it in class?
I'm having that student on hold for.
Yeah, sorry. So, I was saying about, we did the question of fish and the bird, where you understood that whenever light is travelling from a denser medium to a rarer medium, the apparent depth is lesser than its real depth. Whereas, whenever light is travelling from a rarer medium to a denser medium, apparent height or apparent depth, whatever you call it, will be more than the real depth. You remember this or not? Okay, let us take another question where we have multiple mediums. Imagine that you have 3 mediums here. Okay, this has a refractive index of 1, it means it is air. This has refractive index of, assume root 3, some medium, and refractive index of 1 once again. There are 3 different mediums, and there is a coin kept here. Coin is at a depth of 10 centimeter from this layer. Okay, and here we have 20 centimeter thickness, and once again 20 centimeter above it we have a person who is viewing the coin. Is it clear to you? Root 3 ke badla, for making it little simple, let me take it as 1.5, whatever it may be. So, is the question clear to you? Condition clear to you? Condition is, there are 3 mediums. The first one, the topmost medium, is having refractive index of 1, the second medium is having refractive index 1.5, and third medium is having once again refractive index of 1, and there is a coin kept in the third medium 10 centimeter below the interface. Now, the question is, what is the apparent depth of the coin for the eye? Find the answer. Question is, what is the apparent depth of the coin for the eye? Make it fast. For the eye, what is the apparent depth of the coin? That is what the question is. Give a try. Give a try. Any answer? Just a hint for some people who are having struggle. First, we will take this interface and we will find what is the apparent depth. So, first what will happen, light will start from here, isn't it? It will go to this medium first, then only it will go to this medium. So first we will find for this interface 1.5 and 1, what is the apparent depth? How much you are getting? 15. Let us check that. So the formula is d dash is equal to mu 2 by mu 1 into d, isn't it? This is the formula. So mu 2 is 1.5 here and mu 1 is 1 times of depth is 10. So as he told Karthik Balan very correctly, it is 15 centimeter. It means that this coin, which is really at 10 centimeter, is going to be at 15 centimeter for whom? For somebody who is seeing from this interface, isn't it? If my eye would have been here, then I will say this 15 plus this value as the answer. But unfortunately, my eye is not there. Now, for this medium, the real depth becomes how much? 20 plus 15. It becomes 35. And for this 35, I will once again find what? Apparent depth. So it will be d dash is equal to, what is mu 2? 1. What is mu 1? 1.5 times, what is this now? 35. What will be that when you solve it? It will become 350 by 115. 5 3s are 570. So for me, I am getting 3 2s are 6 and 1 0 3 3s are 9. 23.33 centimeter. Are you getting the same thing? Check. If you are getting the same thing, it means that this coin from here 23 point, it means somewhere it is somewhere here, the coin's position. How much? 23.33 plus 20. What is the answer then? 43.33 is the answer. Are you getting how it came? Guys, be very careful about this question. Here we are using 2 times the apparent depth equation. First, for this medium, we found what is the apparent depth, and then for this medium, the apparent depth became 35, and then the first medium is 1.5 and second medium is 1. By using that, we found what is the apparent depth. Is anybody having doubt in this question, or shall I take it that you have understood this? If it is clear to you, then I will start a new topic now. Is it clear to you? See if you have any doubt in this, ask me. This level of question can be expected in the board examination. Don't think it is too tough. It's what is coming in the examination. Shall I proceed further? Sure? Everybody is clear? Online will Mithun, Kavya, everybody is fine? Ananya?
Yes, sir.
Ananya, today you missed my class. Thank you very much, sir.
Yes, sir. I wasn't able to come.
Okay. Fine. So now I have a question for everybody. Please pay attention and tell me the answer for this question. If a light ray is passing from a denser medium to a rarer medium, what happens? Away from normal. Going from denser to rarer. So instead of going like this, it is going to bend away from normal, isn't it? My question to you is, whether angle of incidence will be more than angle of refraction or less than angle of refraction? Obviously less. That means angle of refraction is more than angle of incidence. So whenever the light ray is going from a denser medium to a rarer medium, what happens? The angle of refraction is greater than angle of incidence, or I can say light is bending away from normal. Okay. If I increase the angle of incidence, then what will happen? It will also increase. Do you agree with me? And for a particular value of angle of incidence, the angle of refraction may become 90 degree. Do you agree with what I am trying to say? As the angle of incidence is increased, angle of refraction also increases. For a particular value of angle of incidence, angle of refraction becomes 90 degree. This angle of incidence for which the angle of refraction becomes 90 degree is called as critical angle. What is critical angle? Critical angle is that angle of incidence for which the angle of refraction is how much degrees? 90 degree. This phenomena is called as grazing. So what is grazing? Grazing is a phenomena in which the angle of refraction is 90 degree and the light is just passing over the surface. It is going on the surface. That's why it is called as grazing. What may happen if the angle of incidence is further increased? Now the light will reflect back in the same medium from where it was coming. Are you getting? And this phenomena is called as total internal reflection. Give the heading as total internal reflection. All of you give the next heading as total internal reflection. Write the definition. Write the definition. It is the phenomena in which light reflects back in the same medium. Light reflects back in the same medium. Light reflects back in the same medium whenever light reflects back in the same medium whenever angle of incidence is greater than the critical angle. Angle of incidence is greater than the critical angle. Angle of incidence is greater than the critical angle. Next paragraph you can also write critical angle is defined as that angle of incidence for which angle of refraction is 90 degree, for which angle of refraction is 90 degree. I will repeat, critical angle is that angle of incidence for which angle of refraction is 90 degree. I am drawing once again for you, which is, see there are three possibilities. Here light is travelling from which medium? Denser medium to a rarer medium. This is the angle of incidence and this is the angle of refraction. Normal refraction is taking place. When angle of incidence becomes equal to critical angle, then angle of refraction becomes 90 degree, isn't it? And third case, when the angle of incidence is more than the critical angle, then the light undergoes TIR. So this is normal refraction, this is grazing, and this is TIR. Are you getting my point? So what you understand, see deeply, if you listen to me, please pay attention. If light is travelling from denser medium to a rarer medium, then there are three possibilities. If angle of incidence is less than critical angle, it will refract. If angle of incidence is equal to critical angle, it will graze. If angle of incidence is more than critical angle, it will undergo total internal reflection. You may have a doubt that why is the name total internal reflection? Why can't we call it reflection? Because what is happening here is reflection is happening here, isn't it? So why can't we call it reflection? Is it different from normal reflection? It is different. See, if you have a reflecting surface like a mirror or like any water, something, whenever the light falls on it, there are three possibilities. One is reflection, one is absorption, one is transmission. So if a light is hitting a reflecting surface, for example, if light is hitting here and coming to your eyes, you are able to see it is white in color. Do you think all the light falling on it is reflecting? No. Some light is getting absorbed, some light is getting transmitted, and some light is coming to your eyes. So 100% of the rays which is hitting a reflecting surface may not be reflected. Some of them may be reflected, some of them may be absorbed, some of them may be transmitted. But in the case of total internal reflection, 100% of rays whose angle of incidence is more than the critical angle will reflect. That's why the name is total internal reflection. That is the only reason for transmitting signals to longer distances, we are not using reflection phenomena, we are using total internal reflection phenomena. You are using internet, right? Fiber optics you are using. What is the means of internet? Optical fiber. What is the meaning of optical fiber, you know? Optical fiber is just some glass made up of nano material. In micrometer size you will have glass, and in that glass there are two layers. One is called as core, another is called as cladding. Cladding is the outer layer and core is the inner layer. Core is made up of refractive index in such a way that medium is denser, and here the medium is rarer. So whatever light is entering inside, now it is going from what to what? Denser to rarer. They will make sure that whatever is entering inside, they are undergoing TIR, so that light keeps on reflecting. And what we do, whatever data we have, it is converted into light signals. It is fed into the optical fiber, and since it comes in speed of light, what is speed of light? 3 lakh kilometer per second. In 1 second, the information can go from here to any part of the earth within 1 second. That's why we are able to get the high speed internet. Today you are having high speed internet, right? How, by what means? By the means of optical fiber. How it works? Whatever data you are using, that is converted into light signals, and light is made to pass through optical fibers in such a way that it is undergoing total internal reflection. That's how it can go to very, very long distances in very, very less time. I hope you are getting my point. That is a very important application of TIR. First you copy this first. Whatever diagram I have on the board, please copy it. I hope I am able to, you are able to hear me, right? All of you? Kirti, am I audible? Are you able to hear me? Yashwant, Ivan, am I audible?
Yes, sir. Yes, sir.
Yes. Okay, fine. Have you written this? Okay. Now, if I ask you how to find this critical angle, it's very simple. Please pay attention. You know very well, see here, I am using Snell's law here. This is mu1, this is mu2. So, it will become mu1 sin IC is equal to mu2 sin 90 degree. Do you agree with me? Mu1 sin I is equal to mu2 sin R. Now, what is mu1 sin IC is equal to mu2 sin 90 is 1. So, from where I get sin IC is equal to mu2 by mu1. That is how you find the value of IC. Critical angle will be sin inverse of mu2 by mu1. Generally, we take rarer medium as air and denser medium can mean anything. So, if mu2 is equal to 1, which is for which medium? Air. Then you will get sin I, which is sin IC, is equal to 1 by mu. Do you agree with me? So, this is also a formula which we are using to find the value of IC, which is sin inverse of 1 by mu. Are you getting my point? Very important formula. Today we will use this formula for any numerical solving. So, critical angle is equal to sin inverse of 1 by mu. Copy it up fast. Critical angle is sin inverse of 1 by mu. That is how we find critical angle. Yesterday itself I told you that Snell's law is very important. In many places we will use Snell's law. Mu1 sin I is equal to mu2 sin R, and you are seeing we are using it. Shall I proceed? Have you copied this? One more information for you. Generally, we will have the first medium as glass and second medium as air. So, for glass, you know what is the value of mu? 1.33 is for water, 1.5 is for glass. So, sin inverse of 1 by 1.5 is critical angle for glass, and that is equal to, you know how much? 42 degrees. You can remember this. So, critical angle for glass is how much degrees? It means that if a light is entering into a glass with an angle less than 42 degree, it will undergo refraction. Equal to 42 degree, it will go grazing. More than 42 degree, it will undergo TIR. Is it clear to you? Let us take some questions to be more clear in this. Shall I give some question now? Take the first question. Piece of a glass, light is entering like this. This angle is 42 degree. It is a glass obviously, so it is having refractive index of 1.5. outside is air. You have to complete the path of the ray. The question is complete the path of the ray. First question is this. Give a try. Second question also I will draw here. Every question it is glass and air only, okay. Okay, this much first to do, or these 4 questions you solve first. All of you, make it fast. The 4 questions. Interesting questions if you are able to understand the concept. So there are 4, in front of you there are 3 diagrams. I want you to complete the path of the ray in each diagram. Give a try, I will help you in all the questions. I will come and see how you are drawing. Hello. Andrew, is it possible for you to join the class after some 20 minutes? Around 8:30 around? Okay, okay, join then at 8:30, okay? Link I will be sharing, new link is there, okay? There is a different link, I will share with you in the WhatsApp, okay? Is it done? Please check your answers, okay? I am going to do it now. Check your answers whether what you have done is right or not. Fourth one I will show you. First let us do these three. Huh? Let us see, let us see, let us see. You are wrong. Let us see. Huh. See what will happen. TIR. Let us see, let us see. The moment the light is hitting here, you will draw normal. If this is 42 degree, is this angle of incidence? How here? Angle of incidence is angle made with the normal. See, these things are given to confuse you. Don't make mistake, please. 48 degrees more than 42 or less than 42? What will happen? TIR. It means that light will go and hit here with an angle of how much? 48 degrees. If you stop here, you lose half mark. It's a 2 mark question, 1 mark only will be given if you stop here. Because you must see what happens after this also. It's your duty. How to check that? We can check easily. If this is 48, what will be this? 42. This is how much? 90. How much will be this then? 48. If I draw normal, what will be this angle of incidence? 42 means what? Critical angle, grazing, it will come out like this. Anybody has drawn this full diagram? 2 mark. Half diagram, 1 mark. If you did grazing here, 0 mark. 0 only, no? Are you getting what mistake you are doing? You are seeing 42 degree, you are thinking angle of incidence is equal to critical angle, you are doing grazing. It's wrong. No grazing in the first interface. Only in second interface grazing will happen. Is it clear to you what I have done? It's not a very big question. If your concept is clear, this is very simple question. If anybody has doubt, ask me. If there is no doubt, I will go to the next question. Next question is normal incidence. Why do I say normal incidence? Because this is perpendicular. So it will go straight inside like this. It will hit here. It is 45, 90. How much will be this? 45. 45 means, careful. It's not the angle of incidence. But luckily here, you will draw the normal. It will also be how much? 45. 45 means what? More than 42 degree. TIR. So it will go making an angle of how much? 45 degree. If it is 45, this will become 45. 45, this is 45. 45, 48, this will become 90. It means what is this? Normal incidence. It will straightly come out. If you have drawn this diagram, you will get marks. Everything should be clearly drawn. These questions have come in the board exam. Check the papers. Last question in this page. Once I normal incidence, it will go inside. 30, 90. How much will be this? 60. I will draw a normal. How much will be this? 30. If this is 30, is the angle of incidence more than critical angle, less than critical angle? Less than critical angle. What will happen here? Refraction will happen here. What you will use? Snell's law. Mu1 sin I is equal to mu2 sin R. What is mu1? This medium, I told you it is glass. 1.5. What is I? 30 degree. Mu2, 1. We can find sin R. So 1.5 by 2, sin 30 is 1 by 2, right? Is equal to sin R. So R will become equal to sin inverse of 0.75. How much ever? I don't know the value of it. So with that angle, it will, one thing is very sure, going from denser to rarer medium, it will go away from normal. So it will be this, and what is the angle? It is sin inverse of 0.75. You will get full marks if you draw all this. Are the 3 diagrams clear to you? If there is any doubt, you can understand, you can ask me. See, everything has happened here. Refraction has happened here, TIR has happened here, grazing has happened here. These 3 questions teaches you everything. So that's why I am saying you, whenever a light is hitting a surface, check whether its angle of incidence is more than critical angle, less than critical angle, equal to critical angle, and then decide whether it will go refraction, grazing or TIR. Shall we see the next question, last question that I gave you? In this question, try by yourself now, simple question only. All of you try, make it fast, give a try. Done? Let us wait for a minute for others to finish. Got the answer? Guys, have you got it? Once again, normal incidence, it will come straightly inside, it will hit here. 60, 90, it will be 30. So, angle of incidence will be 60. 60 is more than 42 or less than 42? What will happen? It will undergo what? Total internal reflection, obviously. I will draw it once again like this. So, it will go like this, isn't it? Became very small, but let us draw 60 degree, it will become 30 degree, 30 degree, it will become 60 degree, 60 and how much is this? 90, it will become 30, this will once again become 60. Are you getting what I am trying to say? If it becomes 60, once again you will have 60 degree. It will go like this. Are you understanding what is happening? This will be 60, this will be 30, 30 and is 30. How much is that? 30 and 30 is 60. So, what is remaining? So, it means that I have drawn little wrongly. Should have been like more like this, isn't it? Then only it will become 120. If it is 120, I will draw normal. What is the angle of incidence now? 30, isn't it? And this was how much? This was 30 degree. So, this is 30 degree. Now, what will happen? It will undergo refraction. So, now you have to find the angle. And how do you find the value of r? Mu 1, which is equal to 1.5 sine 30 is equal to 1 sine r. Same like the previous question, r will become sine inverse of 0.75. Patiently, calmly, one by one, you should solve all these kind of questions. So, here it was 60 degree, it went TIR. Once again, we checked here it is 60 degree, it should go TIR. When it is touching here, it becomes less than critical angle, it will undergo refraction. Again, I am repeating, guys, if they ask you to complete the ray, you cannot stop somewhere. Here we have 1, 2, 3 reflections, 3 conditions actually. First here, then here, then here, then here, actually 4 times. All 4 has to be done. If you have doubt, you can ask me. If you have any doubt, feel free to ask me. Any problem in this type of questions? Understanding what is happening? Practice only will make you more better, but it is not something very tough. Yeah, Amruta, please ask me. Amruta, please, louder. Be little louder, Amruta. Can I repeat your asking? Your video is off, your audio is very feeble, I don't know what you are saying. If I understood you correctly, you are asking to repeat it.
Yes, sir.
Why is your video off, by the way? Easy to say network issue, okay, fine. Pay attention anyhow. 90 degree this is. This is how much degrees? 60 degree. Now, this little ray is coming like this. This ray is coming normal incidence. So, it will straightly enter inside. After entering inside, it will go and hit here. Amruta, be unmuted for some time. Is it clear to you how the ray came and hit here? Straightly? Okay. This was 60 degree, this is 90 degree, this will become 30 degree, right Amrita? I will draw normal here, this 30, this will become 60. Say yes. So it is 60 degree, this angle is more than the critical angle. What will happen? It will undergo TIR. So it will go like this, making an angle of 60 degree once again. If it is 60 degree, this is 30 degree, this is 30, this is 90, this is 60. If this is 60, I will draw normal, this will become 30. It was wrong last time what we did. If it is 30, it will come out from here itself. I don't know why I took 60 that time. If it is 30, it will come out from here itself, and now this is 1.5 mu. So it will become mu1 sine I is equal to mu2 sine R. So mu1 was 1.5 and sine 30 is equal to 1 sine R. If you solve this, R will become sine inverse of what? 0.75. So it will go away from normal, it will go like this. This is the correct diagram. I don't know why I took 60 degree and it was wrong previously. Thank you Amrita, at least you made me to correct the mistake. This is the correct answer, okay? Did you understand Amrita? So at any point, you have to properly check with all the angles whether it is undergoing refraction, TIR or grazing. Is it clear to you? Any problem? Everything is clear up to here? If yes, give the next heading as circle of illumination. See, these topics are not there in NCERT, but there is a question in exercise based upon this concept. So let me teach the concept itself to you. Heading is circle of illumination. Circle of illumination. Circle of illumination. Please pay attention. Everybody, please pay attention. Circle of illumination is a concept of TIR only. It's an application of TIR. Have you seen swimming pools? Swimming pools at night will look very beautiful, generally, if it is not dirty swimming pool. Generally it looks beautiful, especially if you see in hotels and all, they will have it brightened at night. And you know one thing, for making a very beautiful swimming pool, they are putting lights in the bottom of swimming pool. And we need not to put too much lights in the bottom because of the effect of circle of illumination. What is that? Let us see that. So imagine you have a swimming pool like this, water body is there, okay, and we have water in this. I am having a bulb here in the bottom part. There is a light, is glowing. So when the light glows, light rays will come out from the light and it will travel like this, like this, like this, it will travel, isn't it? Now, if light is traveling like this is the angle of incidence, it will get refracted, traveling from what medium to what medium? Denser medium to a, so angle of refraction will be more than angle of incidence, isn't it? For a particular angle of incidence, light starts to what? Graze, giving a shining effect. And whatever light is going to have more than critical angle, it is going to undergo what? TIR. So one light ray is coming, undergoing TIR, once again hitting the bottom, once again going above, it is creating illumination throughout the swimming pool. We need not to put many lights inside, because one light itself, only up to angle of incidence being critical angle, it is going to come out as refraction. Rest all the lights will start going inside the medium itself, once again going and hitting the floor, creating a brightness effect. So with 1-2 lights in the bottom, the whole swimming pool gets illuminated. Moreover, if I see from the top, imagine this thing will happen in all directions, right? Here also it will happen. If it is IC, it's going to undergo grazing. So if you see from the top view, it will look like this. So this is a swimming pool. You will be seeing a circle of illumination. And what is a circle? It is its boundary is grazing boundary. Are you getting my point, what I am trying to say? See, this is the, imagine in 3D here, there is a light here, 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 everywhere where the angle of incidence is equal to critical angle grazing. So all these grazing lines will make a circle, and that circle is called as what? Circle of illumination. Ask me, Sharan.
Sir, but the shape of the grazing will depend upon the light, the shape of the light also, sir.
Shape of grazing means what, man?
No, sir. You told, sir, like keeping the light in the bottom.
How circle is forming, you are saying? Why circle? Why not some other shape? That's the question, isn't it? Why not circle, man? See, critical angle is, for example, this is water, it may have, let us assume it is 39 degree. Assume. It means 39 degree in this direction, this direction, this direction. In all directions at 39 degree it will come out, right? It will become grazing, right? So all these up to this 39 degree, less than 39 degree, whatever light was hitting, it was coming outside. And whatever light was hitting more than 39 degree, it was undergoing TIR. So at 39 degree sharp, it will start grazing. So that 39 degree combinedly, we will have circle visible from outside. So if you see from top, you can see light is coming out. Only from where? Only from the 39 degree angle. Are you getting my point? That's why it becomes a circle. Because this is a source. From here, 39 degree, 39 degree, 39 degree, 39 degree, 39 degree. Everywhere it makes a circle. Are you getting what I am trying to say? That's why it makes a circle. And why it is illumination? Because up to this light is coming out, refraction is taking place. It is going to come out. So if you are in 13th floor or 14th floor and seeing swimming pool down, you can see when spotlight is visible on the water. That spotlight will be circle of illumination. Are you getting what I am trying to say? This effect is clear to you. Tell me, Yogit.
Light placed on the walls will also create the side instead of bottom, sides also there.
Sides it will reflect and once again come down. See, multiple reflections will take place inside the swimming pool, and all these reflections will make it more visibility of the swimming pool. Are you getting my point? But circle of illumination will be only in the top. I hope you are getting my point. If I draw another diagram, so something like this, here the light was there, so you can imagine in 3 dimensions something like this. I hope you are able to understand how the illumination is coming. In all the ways it is coming, and this point is what? The critical angle, isn't it? Which is making an angle of refraction 90 degree. So this angle will also be critical angle. Do you agree with me? Interior alternate angle, guys. This will also be critical angle, right? And if this is the depth of the swimming pool, or I am taking it as height h, I can also find what is the radius of illumination. Question is coming from finding the area of illumination. So how do you find radius? Let us see in this diagram what is tan IC. What by what? R by h. And we already know sin IC is equal to 1 by mu. Just now we have learned it. If sin IC is 1 by mu, if I draw a triangle, unit triangle, then this is IC and P by h. So this is 1 and this is mu. Am I right? So what will be this? Root of mu square minus 1. So what will be tan IC? Tan IC is what by what? 1 by root of mu square minus 1. So if I replace tan IC with that, I am going to get 1 by root of mu square minus 1 is equal to r by h. So r will become h by root of mu square minus 1. This is the equation of radius. If they ask you to find the area of illumination, pi r square. Very important for competitive examination, but I have seen NCERT book also has one numerical given in the exercise. This formula is used there. First copy it fast. Make it fast guys. I am very slow.
Sir,
Yes, ask me, man.
sir, in board there is concept Snell's window. So this one is Snell's window. Sir,
Come again, Rishna. In book, what you are saying?
in board in state board syllabus there is one concept Snell's window. Is that
Snell's?
Snell's window?
Snell's window. I have to check, man. I have not heard this before. It may be same. I have to check it. If you can share the photo with me in the WhatsApp, I will be able to give.
I think so. It is this concept only they are calling as Snell's window, sir.
Maybe. I'm not very much sure about
So
that.
it is finding the radius of the illuminated the
Yes,
path.
yes, 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 yes. That only. So if you, those who have NCERT book, if you come to your exercise question number 9.5, you will understand what I taught you now. Exercise question 9.5, the question is like a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the area of the surface of water through which light from the bulb can emerge out? Direct question from this concept, isn't it? So they expect this kind of question to come in the board examination also. But in the book, you will not see any topic called as circle of illumination. But an exercise question is there.
Sir,
Yes, ask me, Premadarshan.
so here the total mirror reflection also takes place, sir.
It takes place obviously, yes.
Sir, are we able to see that reflection, sir?
Yes, what will happen? See, whatever light will come after this, it will go internally inside and this will create more visibility. See, light remaining inside the swimming pool will create more visibility for you, isn't it? So it means that whole swimming pool will be.
Inside the water, sir.
Come again, Devadarshan.
Inside the water, are we able to see that reflection, sir?
Yes, you will be able to see the reflection. Light is getting reflected inside. You will see the light, you will see the swimming pool more clearly at night. If the water is neat, if the water is not dirty. Okay? Is it clear to you? Guys, is it clear to you? Any problem in this?
Yes.
If you don't have any problem up to here and you have copied this, give the next heading as refraction through triangular prism. If everything is clear to you, then give the heading as refraction through triangular prism. Can I go to the next page? Everybody, please tell me, can I go to the next page? Okay. Yes. Refraction through triangular prism. Okay. Please pay attention. I hope all of you know what is the meaning of prism. You know, right? It is a prism, isn't it? What, Sharan Ram? What is this? Triangle, pyramid. And this is prism. Huh? That's the problem with you. You have come to 12th standard by God's grace. Huh? It's not prism.
Sir, if you draw the triangle, the extent is that.
Is this prism?
No, sir.
Is this prism?
No, sir. Sir, the pyramid, sir.
All are pyramid.
Sir, this one no pyramid, sir. First
This-
two I don't know.
This is prism.
Pyramid,
Pyramid. This one?
I don't know.
This is? Okay, let me tell you. Mr. Ivan Rufus. Ivan Rufus. Yes, Mr. Ivan. Which is prism? 1, 2 and 3. Which is prism?
One, sir.
1 is prism. Dishita.
Sir,
1, 2 or 3. Which is prism?
I'll go with 3, sir.
You'll go with 3. Okay. Kirti, I'll come to you. Ivan, I'll come to you. You said your answer. You cannot change. Okay, Kirti.
Sir, I think it's 1.
It's 1. Harvish.
One, sir.
Anshul. What, Anshul? As second. None of them is prism. I'll come to you. Understand what is the meaning of prism. Everybody please pay attention. Understand what is prism first. Prism should have its base and the top as same. One chocolate is there, no? Toddler or something like that. There, right? That is the prism. Prism means whatever shape is there in bottom, the same shape will be there in the top. You know this? Even a cuboid is a prism. Square prism. Even a cube is a prism. Even a cylinder is a circular based prism. Are you getting my point? If bottom and top have same shape, it is called as a prism. All these are pyramids. When you have a bottom and everything is converging at the same point, triangular based pyramid, square based pyramid, rectangular based pyramid, pentagon based pyramid, octagon based pyramid, circular based pyramid is a cone. So first of all, understand, prism means any shape whose top and bottom are same. Here we are talking about which prism? Triangular prism. Means we are talking about this. Base as a triangle, raise, top also as a triangle. This is an example of triangular based prism. And whenever I say refraction through it, you have to imagine that there is a triangular based prism kept like this, like how you have drawn Yogit, something like this. You have to imagine this. What you are imagining, I know, most of you are imagining this only. No, you too. If you are imagining this, then it's fine. Always remember, light will be incident on this surface. It gets refracted inside and it comes out by this surface. Are you getting my point? If this is a prism, light enters in this surface and exits in this surface. It may exit down also, then this and this, whatever. So light enters one surface and exits another surface. Now my question to you is, if I draw this in 2D, I mean like this. If light enters like this, first step will be, you will draw normal, angle of refraction will be less than the angle of incidence, because it's going from a rarer medium to a denser medium. It will go like this. Once again you will draw normal, it will come out like this, isn't it? This angle is called as angle of prism. Don't think that always the top angle is angle of prism. No. Angle of prism, it is depending upon incident ray and emergent ray. If ray goes like this, refracts, comes out like this becomes angle of prism. Are you understanding my point? If ray comes like this, refracts, go like this is angle of prism. You know one thing? If I have a rectangular glass slab, and a ray is entering like this, refracting here and comes out like this is become angle of prism. Even a rectangular glass slab can be considered as a triangular prism if light is entering and exiting from adjacent faces. Is it clear to you first of all? Andrew, if you are able to hear me, your video should be on. Okay. Yeah. And everybody else whose video is off, how many times will I say you to on your video? I don't know. Everything is being noticed. Remember that. Okay. So in a prism, there are various angles. For example, this is angle of incidence. This will be angle of refraction 1. This will be angle of refraction 2. This will be angle of emergence. Not only that, if I extend my incident ray and my emergent ray, this angle will be called as angle of deviation. You must know the relationship between all these angles: angle of incidence, angle of deviation, angle of emergence, angle R1, R2, A. Everything should be known to you. So now first thing what we are going to do, we are going to make relationship between I, E, del A. How to do that? Pay attention. I am drawing a diagram. Everybody be attentive in the class now. So this is the angle of incidence. First step is drawing the normal. I am drawing angle of incidence. Then I am drawing the first refraction. This will be angle of refraction 1. Once again I am drawing normal. This will be angle of refraction 2, and now right will come out, this will be angle of emergence. If I extend my incident ray like this and my emergent ray like this angle is called as what? Angle of deviation, and this angle was angle of prism. All these angles are clear to you first? I, del, E, R1, R2, A, everything is clear to you? I hope it is. If yes, let us try to make the relationship now. So, if you see here, you will realize that we are having a quadrilateral here. Are you able to see this quadrilateral? Visible to you? In this quadrilateral, I can write angle A plus this 90 degree basically, isn't it? 90 degree plus this angle will be 180 minus R1 plus R2. Do you agree? And once again plus 90 is equal to how much? 360 degree, because angle of a quadrilateral is 360 degree. Okay. So, it will become A plus 90, 180, 90. How much is that? 360 minus R1 plus R2 is equal to how much? 360. These two gets cancelled. You get angle of prism is equal to what plus what? R1 plus R2. Always remember, angle of prism is equal to R1 plus R2. Now, if you see, I am once again drawing this diagram here. In this diagram, this was angle of incidence, this was R1, then this was R2, and this was E. If I extend here, extend this was angle of deviation, right? If you see clearly, you will realize that this angle is I minus R1, or let me go to the next page. First you copy this fast. You copy this, I will draw a bigger diagram. It may confuse you, I think. Manasa, I hope you are able to hear me. Video should be on. Everybody else, Class XI, Amruta, I will put you in waiting room, guys. If you don't on your video, no, I am going to put you in waiting room, believe me. One more important thing, I think Andrew, I am talking about Andrew Ranjan and Manasa, you have learned this concept yesterday, isn't it? So,
Yes, sir.
yeah, after this only what I am going to teach you is going to be useful for you. So, maybe you know this concept. So, for 5 minutes you can just revise everything and then we will enter into the new topic. Okay? Have you copied it, guys? Today we learned that also. Angle of minimum deviation, not maximum deviation, minimum deviation. It will come today. It's an important topic for the board examination. One question is certainly going to come from angle of minimum deviation. Have you written this? Can I proceed? Make it fast. Today the class may extend by 15-20 minutes. Those who want to message in their home can message it now. The class today will extend by 15-20 minutes. If you want to message in your home and say something you will come late, please inform your home. I hope you are done with this. Can I proceed further? Litish, Lingesh, done? Okay. So, please pay attention. I am drawing the diagram once again, a more bigger diagram. Where I have my angle of incidence, and then I have the first refraction angle. then I draw a normal, I get my second refraction angle, and then I draw my angle of emergence. As I said to you, if you extend the incident ray and you extend your emergent ray, what angle you get between them is angle of deviation. This was angle of prism. Am I right? Okay. Now, please pay attention. Something very important. Your concept should be clear in that. Careful, guys. So, this angle will be angle I. Do you agree? Vertically opposite angle. This is I. This will also be I. Same way, if this is E, this will also be E. Vertically opposite angles. It means that this angle will be I minus R1. I am talking about this angle. And this angle will be E minus R2. And if you see this triangle, delta, see, you know very well, exterior angle property. This angle will become equal to this plus this, right? So, can I write delta will become equal to I minus R1 plus E minus R2? Do you agree with me? And so, you will get delta is equal to I plus E minus R1 plus R2. What is R1 plus R2? You know it is A. So, I am going to get delta is equal to I plus E minus A. This is the relationship between angle of deviation, angle of incidence, angle of emergence, and angle of deviation, angle of prism actually. Okay? Or you can write del plus A is equal to I plus E, whatever you want to write. Copy it fast. We'll take some questions now. After you're done copying, we will solve some questions from here. Make it fast, please. Make it fast. Shall I give a question now? Shall I give a question now? Okay, please. Take the question. Now, Mansa, Andrew Ranjan. Be alert now, okay? Okay. 75 degree. Refractive index √2. .45 degree. Complete the path of the ray. Once again, complete the path of the ray. This is question number 1. This is question number 2. Complete the path of the ray, or you can write find I and E, whatever. Find E and delta, that is angle of emergence and angle of deviation. You have to find that only. That is the aim. Next question is like this. (30° and 30°, 60°. Refractive index is √3. Right. Solve both the questions. You have to tell me what is the angle of emergence and angle of deviation. In both the cases, solve and find the angle of emergence and angle of deviation. Make it fast, please. Done the first question? Anybody has got the angle of emergence? Come again, Andrew.
Is it 0?
0 you are saying. Andrew, be a little louder, man.
Sir, I didn't get emergence, sir. I only got angle of deviation.
How much is that?
25 degrees, I guess.
Let us check. But without finding angle of emergence, you found angle of deviation is very strange, because
No,
del.
sir, I thought in a prism the angle of incidence is equal to the angle of emergence.
No, man, it is not rectangular prism. In rectangular prism, what you are saying is correct. It's a triangular prism. I and E are not same.
Okay, sir.
Check it. Yes. 45°. 15°. Yeah. What is your answer?
All the prism, like after refracting once again inside, now I'm getting first refract angle of refraction is 30, sir. When I put that
R2, how much you are getting?
R2 43.
but it's not going outside.
Sir, it is coming 90 degrees then again, emergence.
That is grazing.
No, emergence angle is 90 degrees. Along the,
Okay, so
so deviation it will be 60, sir.
let us solve it and check. Guys, I am solving it. Please pay attention. First question, I am solving it for you to teach you how to solve this kind of question. Please pay attention. Again, I am using the versatile Snell's law. I told you it is very important. So, first step is to find, you know very well, light will go and it will have some angle of refraction 1. How to find that? Mu1 sine I is equal to mu2 sine R. What is mu1? 1. What is sine I? Sine 45. What is mu2? √2 sine R. What is 1 by sine 45 is 1 by √2 is equal to √2 into sine R. From here you are getting R as how much degrees? Any problem in this? I don't think you have any problem in this. So you got the value of R as 30 degree. The moment you got the value of R as 30 degree, this is 30 degrees. You know that just now we have solved A is equal to what plus what? R1 plus R2. A is how much? 75 is equal to 30 plus, this was R1 by the way. Yeah, 30 plus R2. What will be R2 then? 45 degrees. So you came to know that R2 is equal to how much degrees? 45 degrees. Now it will come out with angle of emergence. How to find the value? You will use the formula. Once again, mu, that is root 2 sine 45 is equal to what? 1 into sine E. So root 2 into sine 45 is 1 by root 2 is equal to sine E. So root 2 gets cancelled. So E will become equal to 90 degree. It means what? It is grazing. Yes, it is grazing. You may say, sir, but you told for glass it is 42 degree. It is not glass with 1.5 refractive index, guys. It is root 2. So in this case, grazing is happening now. Are you getting what I am trying to say? So what is the angle of emergence? 90 degree. This is the first answer. And you know very well, delta formula I have told you now. What is delta? Delta is equal to I plus E minus A. What is I? 45. What is E? 90. What is A? 75. When you solve, how much you are going to get? 60 is the answer then. Got it? Any problem in this question? If you have any problem, feel free to ask me. If there is any doubt at any point, feel free to ask me, because if you are not understanding this, you cannot even think of solving this. It is a good question. You can solve this question only if you are having clear understanding of this part. Everybody, please have a look properly. If anybody feels difficulty in understanding, feel free to ask me how this has come, if you have any doubt. If it is clear to you, then go to question number 2. Pritika, I hope you are able to hear me. If
Sir,
yes, yes, Andrew, please tell me.
In the first question, sir, you solved with Snell's law and you got R1 as 30 degrees and R2 as 45 degrees.
Okay.
So then after that, again, you use Snell's law to find the angle of emergence.
Yes.
Is that what you do?
Exactly, yes. So first, for this interface, I found angle of R1 by using Snell's law. Then for this interface, I found angle of emergence by using Snell's law.
Okay, sir.
Okay. Fine. Fine, Pritika, I hope you are listening the class properly. If you have any problem, you can ask me. You joined little late, so I thought you may have some issue. If you are clear with this question, start solving question number 2. Make it fast, please. Already time is running late. We are running late. If this question is clear to you, and if your concept is clear for this type of question, then go for next question. Can I erase the board? Anybody has got the answer for the second question? Second question is really good question. You will face challenge in that if you are solving it. E is 90 degree, del is? Del? Find it. You got E as 90 degree or you got R2 as 90 degree? R2 90 means E how it will be 90? It means angle of incidence, angle of refraction is same.
Sir, some different root 3, how
1 by 3 sine, IC is equal to inverse of
angle of emergence is sine inverse
Check,
of
check, 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 check. Huh?
angle of emergence is sine inverse of root 3.
Possible. Root 3 is 1.732. Can sine have more than one value? Yes.
No, sir.
Ah.
In this question,
Sir, I have a question, sir.
Please ask me, Andrew.
Sir, in the first prism, like in
Huh.
the first question,
Huh.
sir, R1 is, you followed as 30 degrees, right, sir?
Yes, yes.
Yesterday, like in yesterday's class, didn't we get R1 and angle of incidence as vertically opposite angles?
No man, no man, no. You forgot then. See, once again I will say you. I said I and this total angle is vertically opposite angle. If this is R1, this will be I minus R1. Remember?
Yeah.
So, yeah, Mr. Jogit, you are getting angle of emergence sine inverse of root 3. Is it possible? Not possible. It means some mistake is there. Check. Yeah, Krishna. Yes, man, that is that's the twist in the question. Can sine have value of root 3? Is it possible to have sine value as root 3? Can sine have more than one value? Then there is something wrong. Question is wrong. Good. Easy to say question is wrong.
Sir,
Yes.
can R2 be 0, sir?
Tell me, Devadarshan.
if R2 is 90 degrees,
If R2 is 90 degree, angle of emergence is coming as sine inverse of root 3. How is it possible? It means something you are doing mistake. Don't say question is wrong.
Can R2 be 0, sir?
R2 is?
Can R2 be 0?
What is the meaning of R2 being 0?
The refraction
Straightly. It means R2 0 can be if light straightly goes out. Let us check. Let us check you are right or not. Huh.
So then no D will be, we won't get any deviation.
Let me solve now. Everybody pay attention. Very good question. This question will teach many concepts to you. Everybody, again this is a board question. See how the question is. Pay attention. Step number 1. Most of you would have done correctly. You would have found the value of R1, isn't it? At this point, light is going to enter into a medium. So you would have found R1 by using Snell's law. You would have used 1 into sine 60 is equal to root 3 into sine R1, isn't it? And from there you got R1 values how much? How much degree you got?
30.
All of you got 30 degree R1? I believe all of you have got this and it is correct. It means that, see this is 30 degree, this will be how much? 120 degree, okay? Please pay attention. 60 and it is going to be 30. If it is going to be 30, this is going to be 60. 120 and 60 are what? Linear pair. It means light will not go and come hit here itself. If it does 60 plus 120 plus 0 degree here, not possible, no? If two lines are having an angle of 180 degree, it means they are parallel to each other. There itself you understand that Me now.
Yes, sir.
Okay. Now everybody please pay attention. Everybody please pay attention. So R1 is 30. It means this total angle is how much? 90 plus 30 is 120. This is 120. This is 30. It means this will be how much? 30. Are you understanding what is happening? This was 90. This is 30 we got. This totally will be 120. This was 30. This will become 30. And now I am going to draw a normal. Okay. What is this angle? What you will do now? You will do, okay, now I am going to find Snell's law using this angle, isn't it? You will do that. Let us try it. So what you will do? Root 3 sine 60 is equal to 1 sine E. What will happen now? Root 3 sine 60 is how much? Root 3 by 2 is equal to sine E. 3 by 2 will become 1.5 is equal to sine. Is it possible? Can sine E be 1.5? Impossible. It means it is not going to go refraction also. It means what? What mistake we are doing? Mistake that we are doing is we are not considering TIR. For that you must find the critical angle. How to find critical angle? Critical angle, that is sine, critical angle, that is sine IC is equal to 1 by mu, 1 by root 3. Now you don't have sine table here to find sine inverse of 1 by root 3, but you have sine of 60 degree value. How much is that? Root 3 by 2. You can compare both 1 by root 3 and root 3 by 2. Which is bigger? Sine 60 is bigger. It means 60 is bigger than IC. It means it is going to have angle of incidence more than critical angle. It means it will undergo TIR. And it will make how much degrees? 60 degree here. Now it will go and this will be 30 degree. This is 30, this 30, this will become 120. So here I will draw normal. This will become 30. Now I will find the angle of emergence. And that will become equal to, this was not applicable. So it will become equal to root 3 sine 30 is equal to 1 sine E. So root 3 into sine 30 is how much? 1 by 2 is equal to sine E. So what came E as? 60 degree. This is correct. So light will come out with what angle? What will be angle of deviation then? 0. Let us check that. Delta is equal to I plus E minus A. What is I? 60. What is E? 60. What is A? 120. How much is that? What? You told E as 0, not delta as 0. Delta will be 0. Huh? Why? Delta is I plus E minus A. I minus A it will come if E is 0. You cannot say like that. E is 0, so delta is 0.
R2 0, E 0, sir.
R2? You hear me now? Guys, are you able to hear me now?
Yes, sir.
Anybody has doubt in this question? Yes.
We have R1, R2 and R3.
R3.
Yes, sir.
Okay, you can take.
R1 is 30.
Okay, take. R1 is 30, R2 is 60, R3 is once again 30.
Then A value how will find? Only R1 plus
See, A value is depending upon which side the light is entering and which side the light is exiting. That side will make angle of prism, isn't it? If light enters here, exits here, angle of prism is this. And one thing is very clearly visible to you, entering at 60 degree, exiting at 60 degree, no more deviation is happening, isn't it? So that you can say 0 degree without even minding. Is this question clear to you? Once again I am repeating, this question is teaching you many other things. Apart from this answer, it is teaching you many things. Any doubt? Ask me. If there is no doubt, I will go to the next concept. I told I will take some extra time today. Is it clear to you? Any doubt? Have you copied it? Everybody copied? Dishita, Manasa, have you copied it? Andrew? Both the Andrews. Can I move ahead then? Can I move ahead? Give the next heading as factors on which angle of deviation depends. Next topic is factors on which angle of deviation depends. Factors on which angle of deviation depends. Factors on which angle of deviation depends. So write the factors first. The first factor is angle of prism. I explain this to you, angle of prism. The second factor is refractive index of prism. Obviously, yes. And the third factor is wavelength of light. And the fourth factor is angle of incidence. Now please pay attention. So you should understand how it depends upon all these four factors. Please understand how it depends upon all these four factors. So as the equation says, del is equal to I plus E minus A. So if angle of prism will increase, delta should increase or decrease? If angle of prism is increasing, delta will increase or decrease? It should ideally decrease, no? But if you check experimentally, it will increase. You know why? Because angle of prism increasing is also changing I and E. This experiment is there in school laboratory. Some of you have done this experiment till now. Angle of minimum deviation experiment, nobody has done till now. Schools are very slow. Okay, this experiment is there, where you will take a prism, and you will take different angle of prisms, and you will find that as the angle of prism is increasing, delta also is increasing. Whereas the equation says it should decrease, but it does not happen like that. Okay, what about the refractive index? If it is increasing, what will happen to delta? Increase or decrease? If I am having prism of higher refractive index, deviation should be more or less? It should increase. It happens like that only. Common sense says that if refractive index is what? It is the property by which bending is happening more. So more refractive index means more bending. More bending means more deviation. So it is true that if refractive index is increasing, delta is reducing. What about wavelength of light? If it is increasing, what is happening to delta? Decrease. Example is red light. If you remember the prism experiment in 10th standard, when I pass the white light from here, what I got here? Vibgor we got, violet, indigo, blue, green, yellow, orange, red, you remember? In that, violet was below, red was? Least deviation was of whom? Red. Because red has maximum wavelength. Violet light had maximum deviation because it has least wavelength. So as the wavelength is increasing, angle of deviation is reducing. Devadarshan, tell me, Devadarshan.
For refractive index, you said angle of deviation will decrease too.
I said it will increase.
Okay.
Okay, for angle of prism oscillation it will increase, and for wavelength I am saying it will decrease. For wavelength I am saying if the wavelength is increasing, angle of deviation will reduce. Light having more wavelength will have less deviation, and light having less wavelength, more wavelength will have less deviation, less wavelength will have more deviation. Last is angle of incidence, the most important one. Please pay attention now. What do you think will happen if angle of incidence is increased? And this is the experiment of 12th standard. What they will do in laboratory, if you do the experiment, they will take a prism and they will pass the incident ray at various angles, 20 degree, 25 degree, 30 degree, 35 degree, 40 degree, and in tabular column you will write the value of I, you will write the value of delta. And you will notice that as the angle of incidence is increasing, angle of deviation is reducing. As the angle of incidence is increasing, angle of deviation is reducing up to a certain point, beyond which angle of deviation once again increases. I am repeating this. As the angle of incidence increases, the angle of deviation reduces up to what? A certain point, beyond which angle of deviation once again increases. This point where the angle of deviation is minimum is called as angle of minimum deviation. So, there is a particular point where the angle of deviation is minimum, and that angle is called as angle of minimum deviation. I hope you get my point. Now, if you see, for any other angle of deviation, if I draw here line, for any other angle of deviation, I have one I, one E, one I, one E. Are you getting my point? But for this particular point alone, there is only one point. It means at this point, angle of incidence becomes equal to angle of emergence. So, you are understanding that at angle of minimum deviation, angle of incidence is equal to what? Angle of emergence. And not only that, even the angle of prism will become equal to angle of deviation delta. We'll talk about that. But first, this is clear to you. Remember that this can be done experimentally in the laboratory also. When you keep on increasing the angle of incidence, the angle of deviation is reducing up to a certain value, beyond which if angle of incidence increases, angle of deviation once again increases. That particular value where the angle of deviation is the least is called as angle of minimum deviation. And if you understand this, one concept is there. See here, whenever light is entering a prism, it has one angle of incidence, it has one angle of emergence. Are you getting what I am trying to say? So, for all the angle of incidences, I have one angle of emergence. So, for a particular value of delta, I should have both I and E, and they may be different. That is why when I drew the graph, I came to know that for all delta value, I am getting one angle of incidence and I am getting one angle of emergence. Same some other delta value, I am getting an angle of incidence, I am getting an angle of emergence. Only for delta minimum, there is no two values of incidence. It means at that point, angle of incidence and angle of emergence are going to be same. It is going to be equal. So, always remember that at delta minimum, what is equal to what? Angle I is equal to angle E. First, you copy this first. Copy this fast, those who are writing, copy this fast. And one more important information, please pay attention. This graph is not a parabolic graph. I have drawn intentionally like this. Don't think my handwriting is bad. This graph is a right side inclined parabola or right side inclined curve, whatever you want to say, inclined curve. This is intentionally drawn. I will give you one question from NEET, even though it can come in school now, but it had come in NEET. One question I will give you now from this concept. Copy it fast first. If you are writing something, please copy it fast. Then I'll give you one question. I is equal to E and also R1 is equal to R2. Both you can write. At del minimum, I is equal to E and R1 is equal to R2. Can I go to the question now? Shall I give the question now? All of you have copied this. Take this question. Interesting question. As I said, this question has come in NEET earlier, but it can now come in school exam also. Please, please, all of you pay attention. How the question is, actually graph is not given, I have drawn it for you. Question will you write, for a particular prism, make it fast, for a particular prism at I is equal to 32 degree, at I is equal to 32 degree, I means angle of incidence, I is equal to 32 degree, delta is equal to delta minimum. So it means that delta minimum is occurring at what degree? 32 degree of incidence. What is the possible value of E? E means angle of emergence. What is the possible value of E for I equal to 25 degree? What is the possible value of E for I equal to 25 degree? Options you take. Options are 37 degree, 38 degree, 39 degree, 40 degree. 37, 38, 39, 40. 39.
Can I repeat the question?
Question is, for a particular prism at I is equal to 32 degree, delta becomes delta minimum. What is the possible value of E for I equals to 25 degree? What is the possible value of E for I equals 25 degree? Options are 37, 38, 39, 40. Yashwant says 37, Shweta says 39. Anybody else? Anybody else, please, if you have any answer. Any answer? Anybody? Here I have got two answers. One boy says 37, changing it, 39. Okay, 39 is the answer told by him, her also. So I have got 39 degree as answer here. Anybody else wants to add some answer? Pratap, yeah?
39.
39 degree, okay. 39 degree, Yogit. Manasa, any answer?
39.
39. Anshul, what about you? Solving this much time. Make it fast. Ivan, what is your opinion?
Sir, 39, I guess.
Kirti, what about you?
I didn't finish it.
Try. Andrew, Ranjan, what is your opinion?
Sir, I don't have an answer yet, sir.
What about you, Andrew Ebenezer? If you are not sleeping behind the camera.
37.
37. Okay. Pritika, any answer? 39. Okay. Let us see whether 39 is right. Majority of you are saying answer 39. What is your answer, Kartika Balan? 39. Yes. Anybody else? Any answer? Let us see what is the correct answer. Please, everybody. 5 minutes time I need from you. I will finish after that. So what did, I know the graph of angle of minimum deviation. I will draw the graph first and then I will find the answer. So they have told that angle of minimum deviation has come at what angle? 25 degree, yeah? 32 degree. Okay. What they are asking, for angle of incidence to be how much degree? 25 degree. What is going to be angle of emergence? So if I take 25 degree and if I draw a line here and then if I draw a line here, you understand that this distance is going to be more than this distance. How much is the difference here? 7 degrees difference. This difference should definitely be more than 7 degrees. Do you agree? Do you agree or not? It can never be equal to 7 degree. It can never be less than 7 degree. It has to be more than 7 degree only. That's why in all the 4 options, only one option is more than 7 degree, which is 40 degree. If I would have given the option as 41, 42, 40, then it is not possible to find the answer. But I gave the options carefully. 37, less than 7, no possibility. 38, no possibility. 39 is confusing, which all of you told the answer 39. It means you assumed that it is a parabola, isn't it? Only if it would have been parabola, then what you are saying is correct. Yes, these both will be same. I stressed this point and told you that it is right side inclined curved, not a parabola, isn't it? I said that or not before some time. Why I said that? Because I know this mistake you will make. And as I expected, I gave the question, you made the mistake. So answer can never be 39, answer is what? 40 degrees, because 40 degrees is the only option where the difference is more than 7 degree. Is it clear to you, everybody? Anybody has doubt? No? Sure? Okay, before we wind off, then let us derive the formula of angle of minimum deviation. Okay? So now we have come to know that, at angle of minimum deviation, I is equal to E and R1 is equal to R2, isn't it? I want to find refractive index of prism. You know that refractive index formula is what by what? Sin I by sin R, isn't it? This you know. I want to find I want to find R. How I will find? Please pay attention, guys, please. You know that angle of prism is equal to what plus what? R1 plus R2. Since R1 R2 are same, if I take this as R, I can write A is equal to 2R, or I can write R is equal to A by 2, isn't it? Same way, I know delta is equal to I plus E minus A. From here I can write I, or II is same, so I will write 2I is equal to delta plus A, and this is actually delta minimum, if I am right, it is delta minimum. So I can write I is equal to delta minimum plus A by 2. Do you agree with me? I got R. So from here you get mu of the prism is equal to sin A plus del min by 2 divided by sin A by 2. This is the relation of angle of minimum deviation with refractive index of prism. Very important for the examination, remember this. It is very important for the examination. Mu is equal to sin A plus del min by 2 by sin A by 2. And very soon in school laboratory you will do experiment based upon that, at least theoretically in school. Check your lab manual today itself, it will be there. Sin A plus del min by 2 by sin A by 2. If you have done this, after you copy this, you can drop off. We will meet again for the next class where I will teach you refraction by spherical surface. Relation between angle of minimum deviation and refractive index of prism. relation between angle of minimum deviation and refractive index of the prism.
Sir, for small angles you can take A plus del met by 2 by A.
A plus, yeah, we can take.
Thank you, sir.
Okay, take care. Those who are done, they can start dropping. Thank you, man.